Welcome to May 31st, 2023. Here we are, last day of May. Your Day Weather Podcast brought to you by Cowboy State Daily. Well, as we head into the second half of the week now, there's really nothing different coming. Some subtle changes, but we're still going to have a lot more showers and thunderstorms. Great shot here from Brian. This was with a severe thunderstorm last week up by Meeteetse that dropped some very large hail. Great shot there of a rotating wall cloud. Never did produce a funnel or a tornado. But boy, it has been a banner month for severe weather watchers and storm chasers across this region. And we'll continue to have this repeating pattern of afternoon and evening thunderstorms across the entire Rocky Mountain West and western high plains. And as we mentioned yesterday, moisture is going to get into the western side of the divide now, so there'll be more activity there as well. Severe weather is mainly going to be concentrated east of the divide, general thunderstorm activity elsewhere. After a warmer day today, temperatures are going to be starting to trend a little cooler, starting tomorrow, but especially for Friday through Sunday. It's nothing terribly cool, but it is going to be a little bit cooler than average, and we're going to have a fair amount of shower and thunderstorm activity and cloud activity over this upcoming weekend. Also, going to spend a time here at the end of the podcast. What is a land spout? Land spout has been thrown about a bit. The word has a lot here lately. We'll kind of show you what the difference is between a land spout and a tornado. Another great shot by Dave Bell out of Pinedale. Rainbow with a shower. Beautiful conditions with the greening prairie out there. Now this shot, just remarkable. Thanks, Carol, for sending this in. This was this past weekend at Lake McConaughey. That's the thunderstorm that you see there, and you're looking up at the anvil, blowing off of that thunderstorm. Just a fabulous shot there, and a fabulous shot of water vapor imagery here, showing exactly the same thing that we've shown you over the last several days. Lots of gray all across the Intermountain West and the Western High Plains. Plenty of water vapor to feed shower and thunderstorm activity. These are the remnants of the showers and thunderstorms that rolled through late yesterday afternoon and evening, finally bringing some rain to some areas of the western Corn Belt, and they may get some more rain here in the coming days. But there's really nothing changing. The pattern is stuck into gear with that low in the southwestern United States, high pressure in the middle of the U.S., and this is by Saturday. So essentially, more low pressure in the west, high pressure stuck in the middle, so the log jam persists. So the persistence forecast continues. If we step through the next 3 days here, these are the lightning strike predictions from the European model for today. You can see the cluster of the heaviest thunderstorms there from southwest Texas north up into the Dakotas, then along the east slopes of the Rockies, getting into areas west of the divide as well. So this is today by late afternoon and evening. And this is where the risk of severe weather will be highest. The darker shaded green, and of course the yellow areas there, is where the severe weather threat will be the highest today. This is for tomorrow. A similar situation with thunderstorm activity all across the region. More of a general pattern of thunderstorms tomorrow. Severe weather more towards the panhandles as we work our way into Thursday. This is for Friday, similar situation, and this is for Saturday. Now notice on Saturday there's maybe not as many lightning strikes. This is as it cools off a little bit. It may be more of a rain shower pattern with clouds and cooler temperatures across the region with that trough of low pressure around. And this is going to produce more opportunities for rain. So we're going to leave May and head into June with essentially the same pattern. So the first week of June, opportunities for more rain, very high over most of the region. And notice western Wyoming getting into the act, western Colorado getting into the act as well as areas east of the divide. And in the drought areas right here, they're going to be able to pick up some more needed rainfall as well, as the last 3 or 4 weeks in that area in the southern plains here along and south of I-70 really finally benefiting from some needed moisture, but elsewhere across the region as well. Now let's talk a little bit about these land spouts that have been popping up, especially across southeastern Wyoming, but across Colorado as well. It's defined as a tornado that does not arise from organized storm scale rotation. So essentially what happens with a land spout is you get a circulation near the ground that is brought into an updraft that then causes that funnel situation where you see what looks like a tornado where it looks like a tornado that's not all quite put together yet. A tornado forms from the circulation within the thunderstorm itself. A thunderstorm will grab a circulation that's on the ground, let's say the beginnings of a dust devil, and bring it into the updraft, which causes the land spout. A tornado is forming in the thunderstorm and the rotation within the thunderstorm. So there's a big difference there, especially in terms of intensity. And this photo and some other photos coming on up from the Cheyenne landspouts really shows this very well. This was the first landspout on May 24th near the Cheyenne area. Notice there's a bit of a disconnection up here from the base of the cloud to what you're seeing on the ground. On this particular day, we had two outflow boundaries merge right over southeastern Wyoming that caused basically a circulation on the ground that was drawn into the updraft of this thunderstorm that formed this landspout. Now, landspouts can produce a lot of wind. You can see the dust there. You can get 70, 80, 90 mile per hour wind gusts in a landspout, so they can certainly cause damage, but they're not going to last very long, and they're not going to bring the intensity of the wind and the destructive power of a tornado. Notice how high the cloud base is. And there's a lot of distance between the cloud base and the ground. That's another clue that you're seeing a landspout. This is the one that happened over this past weekend. Notice again, a very high cloud base and basically only a very, very little discernment right there. Very hard to discern the whole structure of this from the cloud base to the ground. So again, this is another landspout situation where the circulation was drawn into the thunderstorm, not from the thunderstorm. And one thing that a lot of folks were upset about was that why weren't tornado sirens going off with some of these landspouts? Well, if you look right here on the third bullet point, they're difficult to forecast and detect because the rotation is small, shallow, and short-lived, and you really can't see them on radar. In a tornado situation, you'll see the circulation in radar inside the thunderstorm. And that gives really credence to whether or not it's going to be a full-fledged tornado when that rotation is detected by radar in a thunderstorm. If the rotation is on the surface of the ground, being brought into that updraft, the radar, a lot of times it does not have that resolution to see that. You notice how these landspouts are very narrow, short-lived, and so radar detection of these is very, very difficult, as opposed to the circulation that'll show up in a thunderstorm where you're going to get a tornado. So landspouts can certainly be a problem. I think a good analogy, it's very similar to what happens with what's called waterspouts that are very common along the coastal areas of the United States, especially the Gulf Coast, where you'll get a similar situation where they're short-lived. Sometimes those waterspouts will come on into the land and cause some property damage from those strong wind gusts, but they're nothing like what you're going to have in a tornado. And sometimes you'll hear us referring to a cold air funnel situation, very common in spring. And speaking of spring, this is when we see these. The higher humidity air allows it to, in a landspout situation, make it a little bit easier to see the dust and sometimes a little bit of cloud formation in the landspout that is make it easier to see. A lot of times these landspouts will form later in the summer, and sometimes the air is a little bit too dry. And what will happen is you'll see the dust blowing up on the ground, but you won't see the connection from the ground to the cloud. Cold air funnels are very common early in the spring and through most of the spring season. And a lot of times you'll see these this time of year, the month of May especially. This is a tornado. So what you notice here, you see the circulation right here, and notice the base of the cloud is much, much closer to the ground here. Okay, so you've got a mesocyclone. You're going to see on the radar the very strong circulation of the winds, just like this will give you a radar signature. You will not have any signature like that in the thunderstorm cloud in a landspout. So look for the cloud base. If it's close to the ground, you see what looks like a mesocyclone, a wall cloud situation, then you've got yourself a tornado. And then if we go back to that, if you can see the difference right here. Low cloud base, circulation, high cloud base, dust on the ground, a short-lived landspout. Have yourself a good Wednesday. We'll see you tomorrow, the first day of June.